Hello everybody, get ready to do lesson 12.7 of pre-algebra math today, part 1. Part 2 is available here at this email. Worksheets, tests, class worksheets, and vocabulary note-taking guides are all available here as well. And today we're going to do exponential growth and decay 12.7. We have a 32-point class worksheet today, and then we have 7 points here of note-taking students, so pay attention for that. And here's our standards and our objectives. Today's bell work, teachers, today's bell work, write your answer using positive exponents, students. Same thing down here, give your students 5 minutes. Okay, welcome back for our solutions for today's bell work. Here is number 1. You have m to the negative 88th, and so we reciprocate that. And then down here, what do we have, students? M to the negative 9 n squared. We have n squared in the numerator. Then m to the 9th power in the denominator. Because of the negative exponent, we reciprocate. Okay, into our lesson today. Notebook, page 1, students. You've graphed quadratics, you'll graph exponentials now. Musk oxen, that's what our species is here. In 37, there were 39 musk oxen on Nunavik Island. In Alaska, for the period of 37 through 48, the musk population on the island can be approximated by this function right here, where t is the number of years since 1937. After how many years did the muskox population on the Nunavik Island double? And we do that in example 4, and that will be part 2 of this lesson, so email me for that. Here's our muskoxen here. In Alaska, the function p equals 39 times quantity 1.1 to the t power is an example of an exponential function. An exponential function is an equation in 2 variables that can be written in the form y equals ab to the x, where a can equal 0, b is greater than 1. For it to be a growth function, b has to be greater than 1, or rather greater than 0, I'm sorry. And then b cannot equal 1. So it cannot equal 1, it's got to be greater than 0. That's our exponential. That's a pretty good definition here, students, to fill in here for your own words. Notebook, page 3. You've had 2 notebook entries so far. This is 5 points, students. And when this is in my classroom, I check this on Friday, so have it done by Friday. Okay, into our first example here. Graphing an exponential function. Graph this exponential function y equals 4 times 2 to the x. So make a table of values, choose several x values, and then find the corresponding y values. Here's our table. So what do we do with that? Well, we plug in values here for x to find y. When x equals 0, that's always a good place to start. Y equals 4 in this case here. So 4 times 1, 2 to the 0 power would be 1. And then etc. You just plug in here for 1. 4 times 2 would be 8. And then when negative 1, 4 times 1/2 would be 2, etc. So you fill in your table here with these values here, and then what do we do? Use the table to make a list of ordered pairs. So from here, negative 3 1/2, negative 2 1, negative 1 2, and then 0 4, 1 8, etc. So you make a list of ordered pairs here. Now you're prepared to make a graph from that. So first, we're just going to make a table of values, and then we're going to graph the function. So in this case here, students, this is yours. We're going to do this up here. Y equals 3 to the x. Pay attention, okay? So you can do your independent practice. Okay, y equals 3 to the x. How would we graph that? Well, first we make a table of values. Here's your table of values for this function here. Here's our ordered pairs taken from our table, and then we're going to graph that thing. Here's what your graph will look like for this function here. Y equals 3 to the x, so you have something that goes up like this from left to right. And then here's your individual plots here when x equals 0, y equals 1, etc. So that's what you need to do here. Okay, example 2, graph an exponential function. Graph this exponential now. So we have something here that's less than 1. This will be a little bit different. This is actually a decay function. So pay attention for that. I'm just telling you heads up for that one. So we have 1/3 x. So because 1/3 to the x equals 3 to the negative 1 to the x power, we can write it this way. They decided to write it like this. It's not really completely necessary, but it's another way of taking a look at it. So making a table of values now of this function here, what's that going to look like? It's going to look like this. So when x equals 0, y equals 1. When x equals 1, 1/3, 2, 1/9. I mean, it's just another way of doing it here. Then when x equals negative 1, you flip 1/3 and you get 3. And then when it's x is negative 2, you flip it and square it and you get 9, etc. So now we have our table here, and then make a list of ordered pairs. Here's our ordered pairs now from this table. It just makes it easier to plot when you're doing this by hand. So here's our pairs. So now what are we going to do? We're going to try to graph this thing, graph ordered pairs, draw a smooth curve. Here's our ordered pairs. Here's our coordinate grid here. So this is what your graph should look like. It's actually an exponential decay function here because it's falling from left to right. So it is a decay function, and you use these ordered pairs to make this plot here. Okay, make a table of values for the given function, then graph it. So we're going to graph this. We're going to graph this. This one's a little bit different. Students, you need to pay attention to do that. So here's your grid, your tables here. Let's do our guided practice up here. Make a table of values for 1/4 to the x. So to do 1/4 to the x, we're going to make this 4 to the negative 1x, so 4 to the negative x will be another way of doing it. I mean, you can either do it this way or that way. It's up to you. And then here would be our table. Here are values for this function. X equals 0, y equals 1. We know that much. And then the rest of these you plug in. Here for when x equals negative 2, this flips, then you square it, and then you get 16 for that. Then down here, well, I'll let you deal with that. That's yours. Then here's your plot. We have a decay function here because this value here is less than 1. So it is a decay function here. And then here's your plots. And then that's what that graph looks like. Okay? And that was 12.7. Part 1. Part 2 is available here, as well as everything else. Thank you.